Welcome to Math 11 in the AM. We're continuing on with our measurement thing, and I wanted to point something out. The other day when we were recording, I said something wrong, which is not uncommon. I am going to thaw the screen here, and okay, you know this thing here where we did this? We did this conversion correctly, but I was in a hurry and I wasn't paying attention. So we said the conversion is 1 inch is the same as 2.54 centimeters. Good. Said X inches for 80 centimeters. We figured that out. It's 31.85 or 31.5 inches. However, that is really a yes. I don't know why I was thinking backwards. This 30-inch vanity will fit inside the 31.5 inches. That was from the other, okay? So that video has something wrong. Now I told you to try these. Did you try these? You haven't? Okay. I'm going to give you some instructions though ahead of time, because I will be marking those. Now we understand perimeter, and that's not a hard concept, right? To add up all the sides. I know you would have gotten that down. Thank you, Jeff. Now with these, you're going to actually use one of my centimeter rulers. I said, don't worry about the inches, okay? No, actually measure the centimeters. You measure the centimeters of one of these sides. You just times 4, you got the whole perimeter. Obviously the triangle times 3, the octagon times 8. Use a centimeter ruler though, I do expect you to do that. Then, the circumference of a circle is the perimeter, the word for the perimeter of a circle, but it uses this formula with 3.14 as a pi value. You probably have a button on your calculator for that button. You might not, if not, type in 3.14. And I think that's where we left off, because I want to talk about area today, so that you can work your hammer. Should be where you are. Some students have already done this. But what do you know about area? Well, we're not going to do this as a pair off with department, but what is area? Great. Is it a line or is this is a length, right? Like if I measure the centimeter. Area, though, let's say that this is 2 centimeters by 3 centimeters. If I was really carefully drawing it, so this is careful. This area, like how many of those centimeter squares I could fit inside the box. In this case, 2 times 3 is 6, and you can literally see I've got 1, 2, 3, 4, 5, 6 of those centimeter squares. So that's what the area is the space that it takes up. The difference between perimeter and area is perimeter is a length, area is space. What do you need to know to measure area? Well, for a rectangle, you need to know a length and a width. You need 2 measurements. And area is measured in square units. So how is area measured? I'll put like centimeters square. That's the example I use up here. The area is equal to 6 centimeters squared when you multiply 2. It could be inches squared, feet squared. It could even things like acres. That's an imperial system thing. Or hectares is a metric. We won't get into hectares. Calculate area by length times width for a rectangle. Why are they always units squared? Because you're literally figuring out how many little squares you could fit in there. Even if it's a triangle, I'm still figuring out how many of these squares can fit in. And it might be decimal squares. Like in this example here, I have something that's 4 centimeters high, 3 centimeters base wide. And if I count these up, I got 1, 2, 3, 4, 5. 1, 2, 3, 4. Then I've got some halves and stuff like this to add up. These portions, you have to add up the decimals. But you know what? There's a formula for this. And it's just imagining, well, if this was a full rectangle, that would be 12. And if I cut it in half with a diagonal thing, I get 6 is what, and all those little decimal squares would add up to 6. I didn't draw it very accurate, but the area of a triangle, you'll see later, that the base times height divided by 2, because it's just half of a rectangle. There's different ways of calculating. I'm getting ahead of myself. Okay. I'm going to just say, well, adding and multiplying are different. But thinking of this, if you add feet plus feet, that's like talking the length and stuff like this. If I walk 6 feet and then turn and walk 8 feet the other direction, how long did I go? You'd say 6 plus 8 feet is 14 feet. It still stays as a length. Whereas if you multiply, you have a 6 foot by 8 foot. 6 foot, 8 foot. You multiply that, you're going to get feet squared because you're going to figure out how many little squares fit inside there. Okay? That's how they're different. They're only the same because they involve feet. But enough about that. We talked about this already. It literally is, the area is how many of these little squares can fit in here. That's, you can count them or you can multiply to find that there's 1, 2, 3, 4, 5, 6. I don't really want you to count the squares. Use the multiplier. If you know the length and the width or the base and the height, you just multiply it. A quicker way to do it. Area is important if you're doing carpentry and other work and stuff like that. So there's actual uses for it, not just math. It may give this idea if you're going to carpet or if you're going to paint walls, stuff like this. You got a home. You would actually do some rough calculations to know how much paint to buy, how much carpet you're going to need, and estimate the price and stuff. They'll charge you. They'll figure it out for you. You can figure it out fast. Calculating areas. Rectangles are easy. Just multiply the two sides, the two different sides, length and the width. If it's a triangle, it's 1/2 the base times height. You can think of that as base times height divided by 2, which is equal to b base times height divided by 2. It's the same as 1/2 divided by 2. I think I found students find it easier to think of it as divided by 2. A square is like a rectangle. It's the same side twice. So just think side times side. We can use the thing square. I'm skipping the perimeter part. People usually understand. But a rectangle is A times B, the length times the width. A parallelogram, on the other hand, you'll often see a diagram with the height given in the middle through a dotted line. It's still base times height, though. It works that way because why? Because some people are like, why? It's kind of like which guy? But it's this way because if I actually cut off this triangle part right here, I moved it over here, I would have a rectangle. See how if I go to base times height, I ignore this part here. I cut this part off and I move that green thing. I just have a rectangle basically, but we don't. But it works that way. Oh, I don't want to do that. So this is why. Well, that's where this that's why the base times height formula works also for a parallelogram, which is like a squashed. Right. Perimeter, just add up. Now, we have this one worked out, but let's do one together. A rectangle. I don't think of it as a formula. I just think, let's add 8 plus the 3 plus another 8 for this side and the 3. That's the distance if you walked around. You're an N. That's how you get the perimeter side. I use it all addition instead of multiplying. Pardon me. I'm going to write that down. The perimeter is equal to 8 plus the 3 plus the other 8 plus another. That is equal to 16. 22. Yep. That's centimeters because that's a length. Whereas the area is the length times width. That's 3 times 8. And we know this is in centimeters. So when I multiply and get 24, I have to put centimeters squared. Now this parallelogram, squashed rectangle, gives 3 pieces of information, so you don't just take everything and add them up. You got to think this through. I'll do the perimeter in blue. The perimeter is going to involve 12 on this side, 6 on this side, 12 on this top side, and 6 on that. I'm going to go 12 plus 6 plus 12 plus 6 and go around the horn. That adds up to 12, 6, 18, yeah, 36. The area, on the other hand, involves the base, 12, and then the height of 5. And that's 60. Now look, my unit was centimeters, so it's going to be centimeters squared. Okay? I'm going kind of fast because some people are done. Some people just need a little hint or two. Well, let's just see now. 37. I got some questions for you. Do these questions, the area and the perimeter. The area is the multiplying, the perimeter is the add up. Okay? Just because something's on an angle like this doesn't mean it's any different. It's just look at it either. Yeah, these ones. Sometimes I'm going to look like this. This is my base for the area. This is my height. Just because you got to twist your head sideways or twist the paper, it doesn't. This one here, I call this the base. This the height. It works. There's a bunch of parallels. Then triangles. Perimeter is easy for this one, but we aren't given a height in any direction. So you can't actually find the area of that example one. You need more information. Just like this, you can't find the perimeter right off the bat, but you can find the area, and that's what you're asking. 10 times 7 divided by 2. I use the divide by 2 instead of fraction. The fraction means more area and perimeter when you're given enough information. And then we got a bunch of those triangles to do. Perimeter only for these. And area only for these. Okay, so read carefully. And then I'm going to area of circles. I'm going to be in centimeters squared, but there's a formula because they're not boxy. They don't have straight edges. So we need a special formula. There's happy. The area of a circle is pi r squared. Square means times itself. Now I'm going to just draw a circle here. First, though, I'm going to get up. Then I'll draw the circle. So what it's telling me is that distance from the middle to the edge is radius of 5. The formula, you don't need to know anything else to find the area. All you do, this pi r squared thing is just 3.14 times 5 centimeters times 5 centimeters again. Just type it in. And it comes up to 78. Okay? So the r squared thing just means write it down twice and multiply. The pi thing just means you 3.14. You have a pi button, you can use that as a shortcut for typing. We're good on that, Jen? Oh, wait, that's it. I'm going to give you enough info to get through this whole thing. Okay? So then you're going to practice the areas of these circles. Just remember radius, radius, radius. There's no diameter. Oh, here's the diameter. You know diameter, though? That's the full distance. You only want the distance halfway across. First thing you need to do is the radius is equal to 6 points. Use a calculator, and I'll use a calculator. 6.4. If you use a calculator, 6.9 divided by 2 is 3.4 meters. Huge. The area of the circle is pi r squared. So I'm going to put that 3.14 times 3.45 meters. And again, you're going to finish the calculation. You're going to have some number squared behind it. Keep it exactly. Okay. So, there's some more problems to solve. That one was a diameter problem as well, so you have to figure out radius first. Then you can solve that problem. Let me see here. Oh. The end is a formula sheet. You need. Let me see. Then I think that's it. Yeah, the rest is just can you do this, can you do it. Okay. You have enough information to finish, and yes. 46? H. Is this the 45? So back to 46. Okay, this here, you just want to copy that down, and then you're good. Okay, I'll stop the recording. Good luck on this section.